Binary numbering is what machines use for numbering. It's made up of two characters, a 0 and a 1. These characters stand for either on or off. Each place in this numbering scheme is a power of 2 instead of 10, like in the base 10 numbering system. A 0 means the power is not counted, and a 1 means it's counted. For instance, if I was to write a number like this would equal the number 3, because I put a 1 in the 2 spot and a 1 in the 1 spot. Let's take another look. Here I have my binary number chart, starting at the right with 1 and then incrementing by a power of 2 in each location. Here I can play around with different numbers. For instance, if I put a 0 here, 1 here, 1 here, 0 here, a 0 here, 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 and here, what number do you think I have? Well, I add the 4 and a 2, and that equals 6. Let's try it again. I'm going to start with a decimal number this time. This time, I'm going to start with the number 40. This is the number that I want to convert to binary. So as I take a look at my binary number scheme, I figure out which two numbers, or 3 numbers, or 4 numbers equal 40, and then I fill that out as needed. This binary number, 40, would look like this. It's also important to know the terminology that goes with binary numbers. One of these locations is called a bit. For instance, just this spot with the 128 is called a bit. 4 of these locations together are called a nibble. So from 128 to the 16 spot would be a nibble. All of these locations together would be a byte, or 8 bits equals a byte. This is going to be important as we move on and take a look at converting hex into decimal. Hex is an interesting numbering scheme that starts with values 1 through 9. Let's look at the hex numbering scheme. Hex starts with 1 and goes to the number 9. Once it gets to 10, it actually replaces 10, 11, 12, 13, 14, and 15 with alphabetical characters. So with hex, the numbers 1 through 9 are the numbers 1 through 9. And 10 is A, 11 is B, 12 is C, and so on to 15. Each one of these numbers represents 4 bits and can be represented in a binary value, which is the chart that you see in the middle. If I want to convert hex into decimal, I simply take the numbers and convert them to nibbles. Sometimes I might see a 0x in front of a hex number. This just signifies that I am looking at a hex number. The numbers that I want to pay attention to are to the right of the x. For instance, 77. Now if I take a look over, I can see that 77 equals 0, 1, 1, 1. I want to start from the right to the left, so I write that out. The first 7 equals 0, 1, 1, 1, which is 4 bits, or a nibble. The second 7 equals another 0, 1, 1, 1. Now as I convert these to decimal, I simply take my binary numbering scheme and apply it to these numbers. For instance, 1 plus 2 plus 4 equals 7, whereas 16 plus 32 plus 64 equals 112. Now I simply take these two numbers and add them together. 112 plus 7 equals 119. Let's try a different set of numbers. I'm going to ignore the 0x and pay attention to the 511. So as you can see, 1 is represented by the binary value of 0001. So I take the first one and I start on the right hand side and I put 0001. And then I take a look at the second number, which is again 0001. And I take a look at the third number, which is 5, and I reference over here, and that's 101, or from left to right, 0101. So I write that number as well. Now when I calculate that from right to left, starting at the 1 spot, the first number I have is a 1. The second number I have, 1, 2, 4, 8, is 16. And so on. Third number I have, 256. And the fourth number I have is going to be 1024. So the decimal representation of 0x511 is 1297.